Alright, so the next thing we're going to do, we're going to talk more in depth about SOHCAHTOA. So, a lot of times they've always picked one angle, and a lot of times they call it theta. It's a Greek letter. But then, we're going to assign each of these sides. We're going to say this is x, this is y, and our hypotenuse is z. We're going to first define SOHCAHTOA, or sine, cosine, and tangent. So, the S stands for sine, and it's always sine of theta, or the sine of the angle. And O over H stands for opposite over hypotenuse. So from theta, the opposite, you go across, okay, is x. The hypotenuse is the one across from the right angle, so z is your hypotenuse. So O and H stand for O over H. But if we look at our diagram, then we would have x over z. Okay. Then moving on to cosine. So cosine of theta is a over h. So there's no a up there, but it stands for adjacent. So adjacent is the one that's touching theta, but it hasn't been planed yet, basically. So it's not hypotenuse, it's the other one that's touching the theta angle. So in our diagram, a over h would be y over z. Okay, notice that sine and cosine are both over the hypotenuse. Okay, tangent is the one that's a little bit different. So the tangent of theta is over a, so there's no hypotenuse there. So opposite, which is x, over adjacent, which is y. So we have x over y. Okay, it's kind of a combination of sine and cosine, which we'll get into a little bit more in depth. Okay, and now we're going to go ahead and do some problems with it. So you might remember this from geometry, you might not. So if I raise this up, I have 7x and 35. I always want to start by circling the angle, or my theta, okay, and then I'm going to label. So across from the 35, which is my opposite, is x. My hypotenuse, which is across from the right angle, is 7. So I think, okay, O and H, what trig function is that? So if I go up here, O and H is part of sine. So I'm going to write sine, and instead of putting theta this time, I'm going to put 35 degrees. Okay, and then O over H, so x over 7. So now we need to solve that. So we're going to multiply both sides by 7, just like we would any other function, to get these to cancel. So x is whatever 7 times the sine of 35 is. And I'm going to figure that out by putting in my calculator. The first thing I need to check is to make sure that my calculator is in degree mode. So 35 is a degree, so I need to be in degree mode. Okay, and we'll talk more about that as we move on. So now I'm going to figure out 7 times the sine of 35 is 4.01. So x is 4.01. And then I'm going to look at it and make sure that makes sense. Okay, it's smaller than hypotenuse, so it does make sense. That one is the first problem. For the second problem, okay, I'm given this angle this time, okay, just like I was before. And I'm going to label, so 45 is what I'm given, and it's attached, but it's not the hypotenuse. Okay, so my hypotenuse is K, and my attached one is the adjacent. Okay, so this time I'm going to use A and H, which is cosine. So the cosine of 53, we plug in that angle measure. And now we do A over H, so 45 over K. And this one looks a little bit different than the first one. The first one, we were able to multiply that out and get our answer. So really, we're going to do the same process, but we have a couple extra steps. So that cancels. I'm left with K times cosine of 53 equals 45. And now cosine of 53 is just a number, so we're actually going to divide that out. So we're left with K by itself. Okay, so when we go ahead and put this as an answer, these cancel, and I get k is equal to whatever 45 divided by the cosine of 53 is, which is something I checked in my calculator. Oh, my calculator's doing weird things. When I say 53 divided by the cosine, I'm sorry, 45 divided by the cosine of 53, for some reason it's disappearing. Once I put it in degree mode once, I didn't have to put it back. This one's 74.8. Okay, is 74.8. And I'm going to make sure that that makes sense. It's bigger than 45, which I expect because it's a hypotenuse. So that does make sense to me. And the last type of problem, which this diagram is kind of hard to see. Okay, so right now they gave you theta as theta, not an angle measure. And then they gave us two side lengths. So this time we have to first figure out what trig function to use. So the opposite of theta is 3, because it's across. And this time I have the attached, okay, or the adjacent. So O and A tell me I need to use tangent. So tangent of theta equals 3 over 6. Alright, so here's where it gets a little bit different. I don't want to say tricky, but I need to be able to get rid of that tangent. The way we get rid of something is to do the inverse function. So the inverse function of tangent is actually the inverse tangent. So if I go ahead and do this, what happens, and I have to do it to both sides, is these cancel out and I'm left with theta. So theta is whatever the inverse tangent of 3 over 6 is. And we're going to bring up our calculator. I know, for some reason it's looking weird. And we're going to hit second tangent, and it brings up the inverse tangent. 3 divided by 6. And it spits out a degree number. So 26.6. So theta is 26.6. And that's degrees. So I know that this angle right here is 26.6 degrees. Alright, so you have a couple more problems. I think only 3 more problems that you need to go ahead and work through on your own. If you need to replay this video, you can. I hope we don't. But use these as an example. When you're finished with those, then you can go on to the unit